Shingarika, please join. Those who wanted to study electrolysis, I am ready with electrolysis. Yes, Kanish. Can we start? Please write something in the chat box. If you are present in the class, please write something in the chat box so that we can start. Shingarika, Kanishk, Archika. Okay, good. Ready? Okay. So, as per your request, we are going to start electrolysis. Do you know what is the meaning of electrolysis? The electrolysis means the word can split into two mean. One is the electro means electricity, that is flow of electron. Lysis means what? That is pertaining to. Okay, so let's see what is electrolysis. It is a process by which an electrical current is passed through a substance to cause a chemical change. Okay, to cause a chemical change. Okay, Kanish, no need to say thank you. You can always ask me. I am always ready with this. Okay, don't worry. So we know that what is electrolysis. It is a process by which an electric current is passed through a substance to cause a chemical change. The chemical change is one in which one substance loses or gain an electron. We know whenever we will discuss electrolysis, always there will be redox reaction. There will be losing of electron and gaining of electron. So during the chemical change, there is always a lose of electron and gain of electron. And for what is required for electrolysis? We require a setup for electrolysis, right? For setup, you require electrolytic cell, right, which is a non-conducting vessel containing the electrolyte. Without the presence of electrolyte, electrolysis cannot be conducted. Without the presence of this, electrolysis cannot be conducted, right? So first thing which we required is electrolytic cell. It should be a non-conducting vessel containing the electrolyte, and these electrolyte can be in the aqueous state or in the molten state, because electrolytes, when they are in a solid state, they can't conduct electricity because ions are not free. So for the conduction of electricity, either they should be in the aqueous state or fused state. Fused state means molten state. Second thing, we should have two electrode. One is positive electrode, another should be negative electrode. These electrode may be made up of same material, but the electrode which is connected to the positive terminal of the battery will be known as anode, and the electrode which is connected to the negative terminal of the battery can be known as cathode. Understood? So electrode which is connected to positive terminal of the battery via metal wire, bulb or key is known as anode, and the cathode means which is connected to the negative terminal of the battery. Both may be made up of graphite, but one will be known as anode and another will be known as cathode. Why cathode? Cathode is a negative electrode, and why the same material is known as now cathode or a negative electrode? Because it is connected to negative terminal of the battery. On the other hand, when we see anode connected to the positive terminal of the battery. So you can see in the diagram, without battery electrolysis cannot be conducted. We should have a source of direct current. So we should have we can either use a 9-volt battery. Understood? Yes, there is no difference in the fused state or molten state. It means same. Either fused state, molten state means same. It means we have melted any substance into the up to the melting point, but ions are not 100% free in fused state or molten state. Molten state means we are converting solid into ion. Now ion, the force of attraction, suppose whenever there is any ionic substance, right, and there will be strong electrostatic forces of attraction between cation and ion. How we can break those because when ionic compound are in a solid state, they can't conduct electricity because of the strong electrostatic forces of attraction. They should be little bit free. So when they can conduct electricity, when they are little bit far from each other, they are not still separated in the molten state, they are not separated, but they are remain with each other, but that strong force of attraction will become weak because of the melting. Okay, so when you pass electricity through them, they can be easily separated, and then they can start moving to the opposite electrode. Suppose cation will always move towards what? Cation means positively charged ions, they will always move towards cathode, and negatively charged ion always move towards anode. Understood? So there is no difference in the molten or fused state. Okay, so what is next? What is next we require? When we switch on the electrolyte, whenever switch is on, means in the case of battery, the electrolytes start dissociating. Just now I have told you, dissociating means breaking down into their ions, right? And then it depends upon the what kind of electrolyte we have used, whether we have used a strong electrolytes, because strong electrolyte means what? All strong acids, bases are what? Strong acids, strong bases are strong electrolytes, and all weak acids and weak bases are weak electrolytes, because weak electrolytes can give only they can give ions and molecules, whereas strong electrolytes can give us ions only. So they can give only ions, strong electrolytes, because they are going to show the complete ionization. So there will be complete ionization will takes place. But on the other hand, if you are taking any weak electrolyte, they will give less number of ions and along with the molecules. So weak electrolyte always contain, there is a board question, so that's why I am paying attention on this point. So weak electrolyte will always have ions and molecule. On the other hand, strong electrolyte will contain only ions, right, when they ionize. Okay, so it means if you are using any bulb, suppose if you are connected to this circuit, one bulb is there, and if you are using strong electrolyte in electrolytic setup, in that case you will see that bulb will brightly glow if you are using strong electrolyte, but bulb will glow dimly if you are using any weak electrolyte, because there will be less number of ions present. So more the number of ions, right, the conduction of electricity will take faster, and the bulb will glow brightly. It means ions are responsible for the conduction of electricity in case of electrolysis. If more number of ions are there, electricity will conduct faster and the bulb will start glowing brightly. In which case bulb will glow dimly if you are using a weak electrolyte. Suppose if you are using a H2SO4 as electrolyte, so bulb will glow brightly. But on the other hand, in the same setup, if we have changed sulfuric acid with acetic acid is a weak acid, so it will not give complete ions, it will give ions plus one H plus ion and one molecule. Okay, that is acetate. So it will give less number of ions. So obviously in this case what is going to happen, the bulb will not glow brightly. And if you have replaced this with any non-electrolyte substance, non-electrolyte means non-polar covalent compound, like ethanol, like glucose, these are non-polar covalent compound. Now if you have used ethanol in that, in place of any electrolyte, bulb will never glow, because no conduction of electricity will take place, because they will not ionize, since in the absence of ions there will be no conduction of electricity. Understood, class? And on the other hand, if you are using any strong electrolyte like H2SO4, NaOH, KOH or HCl, HNO3, these all are strong acid and strong bases. They can conduct electricity faster because they will completely ionize, and as a result they will give more number of ions. Since more number of ions, they will conduct electricity faster. Understood, class? So the process uses an apparatus consisting of the positive and negative electrodes, which are separated from each other in the solution. Electric current enters through the negatively charged electrode, that is cathode, and positively charged parts of the solution travel to the cathode, combine with electron. Now very important portion of electrolysis, very important portion of the electrolysis. Whenever any electrolysis will be conducted, when you see some positively, because obviously when you pass electric current to the molten or aqueous state, the ions are free to migrate now. So positively charged ion means cation will migrate towards negative electrode, that is cathode, and since they are cations and they want to become neutral atoms, so they will be gaining of electron. So they will gain electron, and gaining of electron is reduction. It means reduction will take place at cathode, and that's why cathode is always known as reducing electrode. Why cathode is known as reducing electrode? Because when the electric current will be passed through the electrolyte, since ions are free now, and positively charged ion will migrate toward the negative electrode, and negatively charged ion will migrate toward the positive electrode. So as a result, what is going to happen? We know that positively charged ion, it means they must have lost electron. Now they want to become what? Neutral atom, right? So suppose if we have H plus ion, right? Now H plus ion is a positively charged ion. It will migrate towards negative electrode, that is cathode, and after reaching cathode it will gain electron. After gaining one electron, this H plus ion means hydrogen ion is going to become a nascent hydrogen atom. So nascent hydrogen atom means what? It will become reactive, and two nascent hydrogen will covalently bonded with each other, and they are going to form hydrogen molecule, right? So which process is taking place at cathode? That is reduction, and that's why cathode is always known as. Yes, Archika, understood or not understood, beta? Archika, Kanishk, Kritika. So whenever at a cathode, which process is going to take place? At cathode, reduction. Reduction means what? Gaining of electron, because positively charged will gain electron, and after reaching to cathode, it means that reduction is going to take place. Now on the other hand, when you see anode, negatively charged ion will reach to anode, and there which process is going to take place? At anode. At anode, negatively charged ions are going to lose electron, and losing of electron is what? Losing of electron is what? Losing of electron is means oxidation. It means at anode oxidation will take place, because negatively charged ion will migrate towards negative positive electrode, and there it is going to lose electron, because negatively charged ions are having more electrons. So if they wants to become neutral atom, for that they need to lose electron. Okay, after losing electron they will become nascent atoms, right? Neutral atoms, and then it means which process is taking place at anode? Oxidation. That's why anode is known as oxidizing electrode. You must have observed whenever there is a losing of electron and gaining of electron, there is a one rule for the electrolysis, that total number of lost electron and total number of gain electron both are equal in number. Total number of lost electron and total number of gain electron will be always equal. Suppose in the first case, if we discuss, if we are doing the electrolysis of what? If we are doing what? Electrolysis of sodium chloride, right? So electrolysis is what? Actually it is a decomposition of a chemical compound, that is electrolyte. What we are decomposing? We are decomposing any electrolyte. It can be a salt, it can be acid, it can be base, right? So what we are doing? We are decomposing, okay? In which state we can come? Either in an aqueous form or a fused or molten state, by passage of direct electric current, resulting in discharge of ions as a neutral atom. Why? When they become ions, obviously ion will migrate towards what? Suppose if we are doing the decomposition of sodium chloride, and in the molten state they have sodium and chloride ion, but when you pass electric current through them, so what is going to happen? It is going to give us sodium ion plus chloride ion. This sodium ion will migrate at cathode, that is a negative electrode. There it is going to gain one electron. So gaining of electron is what? Reduction. It means which process is going to take place at cathode? That is reduction. Okay. On the other hand, when you see how many electron it is going to gain, since there is a 1 plus charge on the sodium, so it is going to gain 1 electron. So Na plus 1 electron is going to give sodium neutral atom. It means whenever electrolysis will takes place, the ions is going to convert as a neutral atoms. Here you have seen sodium ion was there, after reaching to cathode, after gaining 1 electron, it will become a neutral sodium atom. On the other hand, when you see chloride ion, after reaching at anode, that is a positive electrode, it is going to lose 1 electron, will become a chloride neutral atom. So we can see that total number of lost electron and total number of gain electron will always be equal. This is a, you can say, the Bible for electrolysis, right? You can see it is a rule for electrolysis. If you want to check your chemical reaction, half reaction of at cathode or an anode, you should always ensure that total number of gain electron and total number of lost electrons both should be equal. Understood, Kanishk? Understood, Kanishk? Shingarika? Okay, have you understood this? Okay, so now you can see the positively charged ions are migrating towards negative electrode and negatively charged ions are migrating towards anode, right? Now after reaching to cathode, they are going to do what they are going to do? Yes, Kanish, tell me. After reaching cathode, which process will takes place? You can see cation is attracted towards this, cation is attracted towards the cathode and anion is attracted towards the anode. So which process? Just now I have explained you. At cathode, which process is going to take place? At cathode, reduction, and at anode, oxidation. Can we say the electrolysis of sodium chloride is a redox reaction? Yes, because both reactions are taking place simultaneously, right? So whenever you want to ensure that electrolysis is taking place, total number of lost electron and total number of gained electron should be equal. Reduction, yes. Understood, Kanishk? Okay. And at anode, which process is taking place? Oxidation. Understood? Okay. Now if you want to find out, if you find, so it means we can say that electrolysis involves a chemical change. Can we say that? Initially sodium chloride was a compound, but after passing electricity through the molten sodium chloride, what is going to happen? It is going to decompose into sodium and chlorine gas, nascent sodium atom and chlorine gas. It means there is a chemical change, and as a result, since both reactions are taking place at the same time, oxidation and reduction, so we can say it is also a redox reaction. So it is a redox reaction, it is a chemical change. So we can say during electrolysis, chemical. So it is also example of electrolytical decomposition reaction, because decomposition reaction is taking place by the action of electric current. So we can say it is a electrolytical decomposition reaction. Now we should know what type of substances can be treated as a electrolyte. And now you can see here, this is a electrolysis setup they have done. Can you imagine why they have used inverted test tube over here? Yes, Shingarika, can you tell me why they have used inverted test tube here? They are going to fill this with any electrolysis. So why they have used inverted? It means the product after the decomposition reaction will be in the gaseous state, and they need, and obviously the gases always come up, right? And then as a result, what is going to happen? Since we have used the inverted test tube, so we can collect gas in the inverted test tubes. Understood, class? Okay. Before that, I would like to ask you something. If I asked you how to identify whether it's electrolytes or non-electrolytes, right? So since you have used, suppose you have used sodium chloride as electrolyte, we have seen conduction of electricity will takes place, because if you attach one bulb in the circuit, bulb will glow in the presence of sodium chloride, bulb will glow in the presence of any acid, bulb will glow in the presence of any base. But how to identify? So what kind of substances should be taken as electrolyte and what kind of substances should be taken as a non-electrolyte? So, chemical compound which conduct electricity in a fused or in aqueous state and undergoes chemical decomposition reaction due to the flow of electron through it can be treated as a electrolytes, right. And electrolytes are generally ionic compounds, right, and particles in the electrolytes are ions only, right, either ions or ions and molecule only. Suppose if it is acid, so in that case ions and molecules can also be there if it is electrolyte, right. So, it means whether it is a strong or weak electrolytes, but electrolyte always either contain ions. Suppose it is only ionic compound, suppose sodium chloride, potassium chloride, aluminum oxide, in that case so we will have only ions if it is ionic compound. But if it is a polar covalent compound like HCl, H2SO4, HNO3, in that case, or acetic acid, in that case we can get what? We can get ions as well as molecules also. But all acids, alkalis and ionic salts will come under electrolytes because they are going to conduct electricity, because they are going to decompose under the after passing electricity through them, right. And as a result they can conduct electricity either in the fused state. Suppose it is an ionic compound, so they can conduct electricity in the fused state. If they are acid and bases, they are in the aqueous state, so they can also conduct electricity. But on the other hand, the compound which do not conduct electricity in the fused or aqueous state, and they will never undergo chemical decomposition. And as a result, since they are, why? Because there will be no chance of ions, they do not contain ions, because they are generally non-electrolytes are covalent compounds. So, they will have only particles, they are not going to have any kind of ions. So, they will contain only molecules. In the board also they ask what does non-electrolytes contain? Electrolytes contain only molecules. On the other hand, electrolytes always contain what? They contain ions if it is ionic compound, they contains ions and molecule if it is a polar covalent compound. Understood, class? So, yes, so that the gases cannot expand, ma'am, otherwise, yes, yes, you are correct, Shingarika. Okay, so now you can see they are discussing the electrolysis of water, but before that I would like to discuss with you something. So, now you know how to differentiate between strong electrolytes and non-electrolytes. Can you give me some example of the non-electrolytes, Kanishk, Shingarika? Like pure distilled water, it is non-electrolyte. We know that pure water, distilled water, almost non-conductor of electricity. Only acidified water, in this case we are going to do the we are going to take acidified water, but if you take a pure water in place of this, no electricity can be conducted. Okay, so no electricity can be conducted, right. So in that case we can say that pure distilled water is almost non-conductor electricity, so it is a non-electrolyte because it is not going to give us any ions. Alcohol, carbon disulfide or organic solvents like kerosene, alcohol, carbon disulfide solution, carbon tetrachloride, carbon tetrabromide, sucrose, glucose, sugar solution, they all comes under category of non-polar covalent compounds. So, they are non-electrolytes. They are not going to give us any kind of ions, so they cannot conduct electricity. So, they will come under the category of non-electrolyte. Now, how will you differentiate between Shingarika, how can you differentiate between, yes, liquid carbon tetrachloride also. So, how can you differentiate between strong electrolytes and weak electrolytes? I told you strong electrolytes will give only ions and weak electrolytes give ions and molecules. So, which substance will have more number of ions? Strong electrolyte. You can see in this case, during the electrolysis of water, we need to add, we know that pure water is almost non-conductor of electricity, right. So, how we can allow water, how can make water to conduct? We will need to add sulfuric acid. Why we need to add sulfuric acid? Sulfuric acid is a strong electrolyte. It is a strong acids. All strong acids, strong bases comes under the category of strong electrolyte because they are the electrolyte which allow a large amount of electricity to flow through them. Hence, they are the good conductor of electricity. On the other hand, weak electrolytes, They are poor conductor of electricity. If you have used, because they are partially ionized, they will give less number of ions as a result. So, since less number of ions, so less amount of electricity can be conducted, the bulb will glow dimly. On the other hand, if you are using in this setup strong electrolyte, like in this case you can see the initially water was a poor conductor of electricity, but when you have added H2SO4 in that, it will increase the ions. And on the other hand, one more thing you can add in that, after adding H2SO4 in this, what is going to happen? More number of ions will be there. H2SO4 will ionize to give 2H plus ion and 1 sulfate ion. This water also in play, because of the force of attraction, it will also ionize to H plus and OH minus. Since because of this, what is going to happen? More number of ions will be there, and because of that the electricity can be conducted. So, what kind of substances can be taken as a weak electrolytes, which will partially dissociate in a fused or aqueous solution, or which contain only ions and unionized molecule, right? Generally all weak acid, weak bases and most salt of weak acids are weak electrolytes. For example, ammonium hydroxide, calcium hydroxide, magnesium hydroxide, all organic acids, right? Tartaric acid, oxalic acid, formic acid, acetic acid, they are weak electrolytes. Understood? So, they can and then sodium carbonate, because it is a salt of weak acid, that is carbonic acid. Bicarbonate, sodium bicarbonate, that is baking soda, that is also what? And then sodium oxalate, it is a sodium salt of oxalic acid. Sodium formate, it is a sodium salt of formic acid. So, because all these are what? Organic acid, and I have told you the salts, most salts of weak acids are what? Weak electrolytes. Understood, class? Yes, absolutely correct, Shingarika. Strong electrolytes will completely ionize. Yes, ma'am, what is the basis of meaning of unionized molecule? See, unionized molecule means you can see the CH3COH is what? Acetic acid, right? When we dissolve acetic acid in water, it gives us H plus ion and CH3COO minus, that is acetate ion. Okay. Now, you can see in CH3COO there is a covalent bonding, right? There is a covalent bonding. So, that is why it is unionized molecule. Generally, when you see H2SO4, there are 2 hydrogen atom and 1 sulfate, 2 hydrogen atom and 1 sulfate ion radical. So, when in the presence of water, it can give 2H plus ion, 1 sulfate ion, in means the 100% it is going to give us only ions. When it is dissolved in water, when we dilute sulfuric acid, it can give us only ions. But when you dissolve acetic acid, it is going to give us 1 H plus ion and 1 acetate ion. In the acetate, you can see the structure, that is CH3COO. It means this is a unionized molecule, because when you see the bonding in CH3CO, how they have attached? With the help of covalent bonding. So, we can treat this as a molecule. Understood, Shingarika? Okay. Now, so if I ask you, how can you differentiate between anode and cathode? We will come back to this. How can you say that what is anode and what is cathode? We have to revise as per your syllabus, right? You know the positive anode is a positive electrode, we know that, and maybe anode or cathode both of may be made up of copper only, or maybe iron only, or maybe it is graphite only. Both electrode are made up of same material, but when they are connected to positive terminal and negative terminal of the battery, both has to be connected to the battery, so that they should be complete circuit. So, how can we say that it is the anode? Why? Because the electrode which is connected to the positive terminal, that is anode. It is electrode which is connected to the positive terminal. Terminal means end of the battery, okay, and negative terminal means end of the battery. So, there are two ends of the battery, one end one electrode, another end another end. and you can see there are two terminals, positive and negative. The electrode which is connected to positive is anode, and the electrode which is connected to the negative terminal will be known as cathode. Understood? So, electrode hence acquire a positive charge during electrolysis. Yes or no? The electrode hence acquire a positive charge during electrolysis, hence ions which are very negatively charged, right, negatively charged, that is anions, migrate to anode, because the electrode because it is connected to the positive terminal of the battery, so it will acquire a positive charge, and because of that negatively charged ions will attract towards this electrode, that is anode. And when you see the that is cathode, so cathode will acquire what charge? Negative charge during electrolysis, hence ions which are positively charged will attract towards or migrate towards what? Cathode. You know, understood? So, anions means donate excess electron to anode. It means which reaction is going to take place at anode? At anode the ions will always oxidize to neutral atom while losing of electron. At cathode the ions are going to become a neutral atom by reduction process. It means they will be ions will reduce to, means positively charged ions will reduce to neutral atom by gain of electron. It means which reaction is going to take place at cathode? Reduction. So, that is why we say anode is oxidizing electrode, cathode is reducing electrode. Understood, class? Understood, class? Now, one more thing. If I say the anode is oxidizing electrode by which electrons leave the electrolyte, loss of electron from an atom or ion is called oxidation. We know that, hence oxidation takes place at anode. If I say chloride ion or oxide ion, so oxide ion is going to lose 2 electron because there is a 2 minus charge. If it is chloride ion, so chloride ion is going to give out 1 electron, okay. So, 1 minus charge will be there. And at cathode, suppose if it is a sodium chloride, so sodium ion will migrate to cathode, there it will gain 1 electron, okay, and it will become a neutral atom. Understood? Now, which case you want to study, which case you want to revise, because we have a, there is a lead bromide case also. Okay. So, which case you want to study, beta? Tell me. Lead bromide or the same electrolysis of water. So, let us study the electrolysis of water. Sodium ion loses 1 electron to get neutral. Why? Why? Because beta neutral atoms will always have same number of electrons and same number of protons. This Na plus charge shows that it has lost 1 electron. This Na plus shows that it has lost 1 electron. Lead bromide case, okay, I will discuss that. Okay, okay, Kanishk, understood? So, why it gains, why it become neutral? Because what we are doing, ions, what we are doing? We are decomposing sodium chloride into neutral sodium atom and chlorine. So, since sodium, this ion will migrate towards cathode, since there is a presence of electron, in that case it is going to gain what? It will gain 1 plus charge, means it must have lost 1 electron, so Na plus. Understood, beta? Okay. So, that is why it will become neutral. After gaining electron, it will become neutral atom, because in that case there will be same number of electron and same number of proton, 11 electron, 11 proton. So, it will become electrically neutral. Okay. So, she wants a case of what? Okay. So, you want a case of lead bromide, okay. Let me explain you the lead bromide case, okay. Now, in the lead bromide case, what is required? See, lead bromide is what actually it is a ionic compound, and ionic compound does not have free ions in the solid state. So, that is why in the solid state they cannot conduct electricity. Kanish, understood? Very good. So, in the solid state lead bromide cannot conduct electricity. Okay. So, it means we have to take lead bromide in a molten state or a fused state. Shingarika, understood? So, it should be in the molten state or a fused state. Okay. So, for that we need to take a electrolytic cell, which should be made up of silica crucible. Why silica crucible? Because we need to heat. You must have seen when we do the electrolysis of lead bromide, we continuously heat lead bromide from the bottom, and in the silica crucible there is electrolysis is going on, and at the bottom we will arrange in a such a manner that we should continuously heat, because when we will stop heating, what is going to happen? Once it is the lead bromide cools down, once again it will become a in the solid state, and then it once again it will become a non-conductor, because there will be strong electrostatic force of attraction between cation and ion. So, we need to maintain them into the molten state. That is why we will continue provide what? We need to continue provide what? Temperature from the bottom, so that we should always ensure that the lead bromide is in a molten state. So, when we use a silica crucible in which lead bromide is kept, right. So, what we need to take? We need to take we need to arrange silica gel in a such a manner that it should be in the stand, and from the bottom we should always keep using any fire, so that the molten, we should keep providing temperature, so that lead bromide should be in the molten state. This is one thing we should know, and that because electricity can be conducted, they can conduct electricity only when they are in the molten state or a fused state. Maybe you have melted and you have kept it for some time and you are doing the setup for the electrolysis. In that case, once again it will cools down and it will become in a solid state, and now ions are not free. When you try to pass electricity can't pass through them. They have once again they have converted into solid state. So, in order to ensure this should not happen, they should remain in the molten state, we have to continuously provide temperature from the bottom while doing electrolysis of lead bromide. Shingarika, understood beta? Okay. Now, I told you which electrolyte we have used here. Since we are doing the electrolysis of lead bromide, the electrolyte will be molten lead bromide. Now, 2 electrode, in this case this can be made up of iron, 2 electrode, it can be made up of iron or graphite, both should be both, and we should ensure that both should be inert. So, in this case we need to take inert electrode. Okay. So, how much temperature we need to maintain temperature, because we know the melting point of lead bromide is 380 degrees Celsius. So, we need to maintain this melting point, so that they should be in the molten form. Okay. And how much electric current should be there through the circuit? Through the circuit it should have a current of 3 ampere. So, what happens when you pass the electric current and you are also ensuring that it should be in the molten state by providing temperature up to their melting point. So, what is going to happen? It will decompose into ion, it will dissociate into lead ion, that is Pb2 plus and 2 bromide ion. Okay, understood? Now, how many ions are present? Since it is in a molten state, so we can't have any aqueous ions, right. So, there are only 2 ions, that is Pb2 plus and 1 bromide ion. If you are decomposing PbBr2, so 1 lead ion, that is Pb2 plus and 2 bromide ions will be there. Okay. So, now obviously this lead ion, since it is a positively charged, it is going to migrate to which electrode? This is positively charged, it is going to migrate to cathode. Cathode is what? Negative electrode. And after reaching there, since there is a 2 plus charge, it means it needs to gain 2 electron. So, it will gain 2 electron, it will become a neutral lead atom. So, at cathode which reaction is going to take place? There is a gaining of electron, it means reduction. It means we can say Pb2 plus ions will reduce to Pb neutral atom by accepting electron, by gaining 2 electron. And please make sure one thing, that number of gained electron and number of lost electron both should be equal in number. Okay. So, you can see since there is a 1 lead ion and 2 bromide ion, so 2 bromide ion going to lose 2 electrons. Okay. So, you can see lead ion is going to gain 2 electron and 2 bromide ions going to lose 2 electron. You can see 2 electron will be gained and 2 electron will be lost. So, once again it is following the rule of electrolysis. What is the first rule of electrolysis? The total number of lost electron and gained electron both should be equal in number. In this case also they are following the rule of electrolysis. So, one lead ion, that is Pb2 plus, after reaching at cathode it will gain 2 electron and then it will become a neutral lead ion, that is Pb. Okay. So, it will be reduced to Pb ion, Pb ion will reduce to Pb neutral atom by gaining of electron. Okay. Now, on the other hand, and lead is what kind of deposit we can see? Silverish grey deposit can be seen at cathode, because lead metal is silverish greyish color. So, what kind of deposition we can see on cathode? We can see silvery grey deposition, because after reaching to cathode it will gain 2 electron, after gaining of electron it will become neutral atom. So, we can see the deposition of the lead metal over cathode. On the other hand, when you see bromide ions, since this is a negatively charged ions, it is going to migrate towards which side? It is going to migrate towards which side? Obviously, it is going towards the anode, and after reaching to anode, 2 bromide ions are going to lose 2 electron and 2 nascent bromine atom will be formed, and 2 nascent bromine atom will covalently bonded and will make a bromine molecule. And bromine molecule, since temperature is high, so bromine is always in the liquid state at room temperature. Since temperature is high, we can see brown color, reddish brown color vapors at which electrode? At anode. Generally, observation of this reaction will be asked. So, you will see that silverish white grey deposit can be seen at cathode, because lead ion after reduction it is going to turn to neutral lead. On the other hand, bromide ion will migrate to anode, and after reaching there it is going to lose electron. It means oxidation reaction is going to take place. It means we can say that 2 bromide ion will oxidize to 2 bromine nascent atom, bromine atom, and then these 2 bromine atoms will covalently bonded to bromine molecule. Okay. So, it is going to form bromine molecule, and that is why, since temperature was high, we were doing the electrolysis of the molten lead bromide, and because of that this bromine liquid will convert into bromine vapor. So, reddish brown fumes can be seen at anode. Which reaction is taking place at anode? Oxidation. Understood? Understood, Shingarika? Shikarika, understood? Okay. So, now why electrodes are inert? I told you, you should see that, you should ensure that electrodes should be inert, since they should not take part in the reaction, otherwise they would prevent the discharge of respective ions, otherwise they will start reacting with that, right. Graphite anode is preferred to other inert electrodes such as platinum, since graphite is unaffected by the reactive bromine vapor. Bromine vapors are very reactive. So, if you use the platinum will combine with this bromine vapor. So, it is better we should take inert electrode which is not going to affect in the electrolysis process. Understood or not understood? Yes, Shingarika, understood? Shingarika, understood? Any doubt in this? And why the crucible is made up of silica? I told you, since we have to ensure that high temperature, that is 380 degrees Celsius, so it should withstand with the high temperature. Second thing, it should be non-reactive. Okay. So, silica is made up of non-reactive substance, it is non-reactive and almost non-conductor of electricity. Electrolysis always almost non-conductor of electrolysis. Okay. Archika understood, Shingarika has not understood. Okay, understood? Any other case? You have test tomorrow? Okay, then I am going to end my class. We'll continue with this topic in the next class. Do you have any doubt? You can ask Beta.